Hello, in this video we are going to create the planet Earth without using any polygons. What I have here is a 22K displacement map, 22K color map, and 22K reflection map. So I'm going to add a null, call it surface, press properties and change it to the new shape primitive type, increase its radius to 0.98, and why it is 0.98 we're going to touch that a little bit later. I'm going to set the accuracy to 1 and turn off the glossy reflections because we are not going to need those yet. What I'm going to add is an image node, load in the color map, set the mapping to spherical on the Y, and connect it to the color. Since we are trying to simulate the Earth, I'm going to first of all increase the light intensity to 25. Of course, our sun is much brighter than that, but it's going to fit our example a little bit better. I'm going to increase the volumetric samples and the surface samples, the shading samples, increase the angle to 5 and make it visible to camera. I'm going to use the node editor to create a black body radiator and set the temperature to 5772, which is the temperature of our sun, and connect it to the luminaire. Next, we are going to add the specular map, and I'm going to use the world reflection for that. Connect it to the specular. And now what I want to do is I want to lower the specular value to 5%. And the easiest way to do that is to if you have the backdrop color is black and the map color is white, these are the reflective parts, and I want those to be 5%, the easiest way is to just make the opacity 5%. And now the white areas of the image map are now 5%. And then I'm going to use this same image. I'm going to copy it, paste it over here, move this around a bit to make room. I'm going to pull it back over to 100, invert the color, and grab a gradient, connect the color to the input, and the color of the gradient to roughness. And then I'm going to remap the black, which is our first key, to something like 45, which makes the roughness 45% in the black areas on the map. Then I'm going to take the white areas on the map, that is the ground material and not the water, and make it fully 100% rough. We're starting to see the surface color maybe too bright, so we're going to use the same technique here. I'm just going to lower the opacity to 40%, and that is going to make our diffuse value 40%, scale the image down 40 by 40 into 40% range. The next thing I'm going to do is I'm going to add or copy one of these nodes again, and I'm going to use our ramp, pull it back up to 100%, and connect the color to displacement. And now you can see that our sphere is nicely displaced. It is sort of like micropoly displacement, but since the shape object is not using any polygons, it is just remarched displacement. It is way too high for a planet to have, so I'm going to decrease it down to 0.01 and maybe find an area on the surface that has even higher displacement. There we go. And we can see that it is still way too high, so maybe all the way down to 0.025, just to get the shading to look nice and to get a nice enough displacement if we decide to look at our planet a little bit closer. So that is now our planet surface, and because I set the roughness to 100% on the landmass, you can see that the light terminator is pretty sharp, as a planet should have. The next thing we are going to do is add another null and call it atmosphere. Press properties and change it to the volumetric primitive. I'm going to decrease the step size to get a little bit better quality shading. Then I'm going to open the node editor, and this is where we are going to build our fall off for the atmosphere. If we look at the atmosphere as it is now, we can see that the fall off is not quite there. It is way too sharp. In fact, there is no fall off. It is just that the volume is optically thinner in these outer edges. So what we're going to do is add a math node, a vector length. We are going to add a gradient, a power function, and a multiply node. So we're going to connect the object position to the input of the length vector, and since our atmosphere radius is 1, it is going to be easy to use the gradient with the object coordinates, because the length of the object's position for each sample taken is going to be in the range of 0 to 1. We're going to connect this to the gradient input and change the first key to completely white, And this is very important. You absolutely must use the linear smoothing because we are going to affect the gradient ramp with the power function. I'm going to add a second key, set it to linear, and put the position to 0.98, which was the radius of our surface. And this way our fall off starts at the exact surface uh, height. Now I set the last key, also the smoothing to linear and the color to black, and it is at position 1. Now we're going to connect the color to the input of the power function. We're going to connect the power function to the multiply node and the multiply node to the scattering scale. The atmosphere now disappeared because the multiply node is set to 0 by default. I'm going to set it to 1 for now, and then I'm going to increase the power to something like 8 to create a sort of exponential fall off. Let's disable the backdrop color completely so we can see a little bit of the atmosphere forming up. I'm going to decrease the step size to get rid of the noise. There we go. Make sure all the keys are in their correct positions. And lock them in place so we don't accidentally move them again. All linear, good. And now we're starting to see our atmosphere forming up. Maybe the power of 8 is too much, so I'm going to decrease it to 4, maybe 2. And now we can start to see a better fall off at the edges of the atmosphere. Of course, it is currently white, which is not correct, but conveniently we have a color that is pretty close to what the Earth atmospheric color should be in the color picker. So we're going to select the third down from the blue column, like so, and this is going to start looking a little bit better color-wise. I'm going to increase the multiplier that multiplies our scattering to 8, and we're going to start seeing a much brighter atmosphere, because when we increase scattering, the scattering means the scattered, i.e. reflected and scattered color of the surface of the volumetric. Next we are going to copy the multiply and paste it right next to it and connect it to the absorption. It doesn't look quite right, so we are going to use the same blue color as the absorption color, and now we are going to start seeing the orange red tint where the atmosphere is the thickest. And let's maybe increase the absorption, and let's increase the scattering as well. And let's take the light and rotate it a little bit. well, actually a lot. And now we can see that where there is a sunset, you can see this red orange uh, tint on the atmosphere color. If we're going to move our camera closer to the planet, there's our sun. We can see that it has a nice sunset color. But if you want to make it a little bit more red, you can always increase these either the scattering, which is going to make it a little bit brighter as well, to get your desired um, result for the sunset. If I rotate the light beyond the horizon, we can see that it's very very red, as it should be. I move the sun high up in the air, and it's going to be blue, as it should. And I'm gonna keep rotating, and we can start seeing the sunset from the other side of the planet, and it's going to start shading the atmospheric scattering effect. Um, right now it looks okay, but it is still missing something. So I'm going to increase the step size a little bit to make it render faster. We don't need a low step size because when we use adaptive anti-aliasing, it is going to take care of the noise a little bit better. So what we now need is another one of these volumetric um, primitives, and I'm going to clone the atmosphere. As you can see, it immediately multiplied on the effect, but we are going to call this haze. And this is very important because there is a haze layer on the Earth atmosphere that is white. Let's set the absorption to white. Edit the nodes. Disconnect the absorption completely. Set the multiply to 1. Actually, let's disable the atmosphere layer so we can see the effect of the haze layer better. Now it is very clean. We don't need that many steps on it. To make it render faster, maybe 10. And then increase the power function to give it a much higher fall off. Maybe 4 will do. Looks fine. Maybe 6, 5. And now here comes the important part for the haze layer. The haze layer actually has an asymmetry of 76 to make it forward scattering. And if we move our camera more, let's decrease the grid size to make the camera movement slower. If we move our camera closer to the planet's surface, we can see that the haze layer is actually producing a halo-like effect around the sun and also reflected from the the bottom layer of the haze. If we want the halo to be a little bit more pronounced on the higher level, we're going to decrease the fall off and increase the scattering to the multiplier to something like 2, and now we have a a glow on the atmosphere. And then when I reactivate the atmospheric scattering, and just for effect I'm going to lower the sun brightness. So there is our pretty accurate looking atmosphere. I'm going to find a better location for the camera. And if I rotate the light, you can see the halo follows the sun, and we can see the fog effect on the surface itself is correct, and the colors on the horizon are all correct. I rotate the light, we can see there's the sunset with a nice halo around the sun. Pretty good colors there. And let's move the timeline back, so we're back in space. Rotate the light a bit and bring the light brightness back up to 75. So this is your basic setup for the planet Earth. Looks pretty good. All the colors are pretty close to what they would be on a real simulation of a atmospheric effect. It is all volumetric, so you can move your camera into the atmosphere. You can have your displacements to maybe fly around the mountains and get a nice render of a terrain with a correct looking, realistic looking planetary atmospheric scattering. Of course, you can see the effect is very bright, and the real sun would be even brighter than this. But you can render this as it is, and then use tone mapping as a post process. Let me show you the effect of HDR exposure, for example, on this relatively bright render. So press P for the properties and see what it would looks like with a white point of 4, and that is much better with tone mapping. And then you can always tweak your the scattering density and the absorption density to make your planet atmosphere look like whatever you want it to look like. If you want to have a more polluted atmosphere, you would increase the scattering and absorption to increase the density. And this should give you a nice enough starting point to start making your own planets. And I'll see you next time.